Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello, welcome to Microsoft Research. Can you all hear me okay? Donna, can you hear me in the back? My name's John Nordlinger. I am running a gaming initiative here in Microsoft Research. And I'm very pleased to announce our visiting speaker, Kelvin Sung from the University of Washington, Bothell. Kelvin's a prolific writer. He's had numerous papers accepted recently at various conferences, including SIGC. Also, Kelvin has recently produced a text, and he's been speaking to standing room only events. So we thought it'd be good to bring him here, both for Microsoft appreciation and for the local folks here to take advantage of. So let's give a warm welcome to Kelvin Sung. The one thing we'd like to do is we'll pass the mic around now, just so you can introduce yourselves briefly so we know who's in the room, and that'll give Kelvin an idea of how to direct the course and us an idea of who the community is. We'll start with Ruth Fruland.
Well, I'm a research associate at the Human Interface Technology Lab at UW with Tom Furness. We've met before. Hi.
Hi, Ruth.
And also, I've begun teaching at DigiPen, which is why I'm sitting at this in this group. And I'm interested in serious games, but from a non-technical point of view.
My name's Matthew Mead, and I am also from DigiPen Institute of Technology. I'm computer science department instructor teaching mainly data structures and C and C++ programming, and I'm always interested in new APIs and frameworks to make games.
Hi, I'm Matt Clausen. I'm a mathematics professor at DigiPen and also dean of faculty there.
Hi, I'm Brandy Grace. I'm a game designer and game instructor at DigiPen, and I love games.
I'm Ken Meerdink. I teach computer science at DigiPen, and don't have any experience with XNA.
Colin Goebel, Department Chair of Computer Science at Portland Community College. Busy developing and expanding our game development curriculum.
I'm Alan Boulay, and I'm a student at the University of Washington, Tacoma, and I hope to get into game development someday.
I'm Kenneth Lewis. I'm also a student at the University of Washington, Tacoma.
My name is Alexandro. I'm a new intern here in Microsoft Research. I'm working with Jean Laurus, and we're trying to find some application where transactional memory could be used, so I'm here to look at it. Great. Thank you.
I'm Dan McCabe. I work at Microsoft on a program called Virtual Earth 3D.
I'm Ann Loomis. I work with Dan on Virtual Earth.
I am Jessica Benner, and I'm also a student at University of Washington, Tacoma.
Hi, I'm Kevin Stovey, and I'm also a student at University of Washington, Tacoma.
Hi, I'm Isabelle Bichandaritz. I'm an assistant professor at the University of Washington, Tacoma, and I'm teaching courses, particularly mixing artificial intelligence and graphics with interactive graphics and gaming.
Hi, I'm Kevin Keeker. I'm a lead in the user research group, the Microsoft Game Studios. And I don't really know how to program, so I'm going to be struggling along here.
I'm Feng Wang. I'm working in Visual Earth 3D team.
I'm Kent Foster. I work here at Microsoft and have collaborated with John Nordlinger over the last 3 years on a conference for game development that we've done on a cruise ship. So you're all welcome to come next year.
Brian Fish, student at UW Tacoma, and I like cruises.
I'm David Weller. I'm a program manager / evangelist on the XNA game platform team.
Jamie Cromack. I'm on the same team that John is at Microsoft Research.
Ken Perlin. I'm a professor of computer science at NYU, and I've been using XNA in our game class, and the students really like it.
Hi, I'm John Grotchen. I work for Microsoft, and I'm just here for because I'm quite interested in XNA gaming.
Donna Fontaine, and I work in Microsoft Research, sometimes collaborating with John Nordlinger, and I also co-taught a class at the UW last year called Digital Play, and I'm very interested in learning more about XNA, and particularly Calvin's teaching.
Okay, welcome all of you. Thank you again very much for coming on a Saturday, especially when the weather's so nice. And here we'll have Kelvin, and then later today, as promised, we'll have a guest lecture from Ken Perlin in the back.
Great. Thank you. I'm going to switch this off now. And thank you very much for coming to this talk, and let me welcome you again. And so what we're going to do is, I was going to start off by asking about who we are, and this is wonderful. John really helped in that respect. May I ask people from the Earth 3D project, what are you guys looking for in terms of your background? You guys have a lot of graphics background?
Yeah, I mean, my primary goal is to learn some of the concepts of XNA, in particular how it applies to 3D.
How it applies to 3D? Okay. And I guess the students from there are a lot of UW Washington from Tacoma students, and you guys have a background in C#. You guys program with C#? Mostly Java. Okay. They're quite similar. And once you start programming with C#, it's a little bit, because of the way the IDE worked, it's a little bit difficult to go back to Java, because all these things are automatic. It's great, but then it's a really bad habit. You start hitting that tab key so often. And how many people here will say that we know a lot about computer graphics, like 2D and 3D graphics? Okay. Some of you need to really humor me here, because so I guess we can save that. And the reason why I'm asking this is that, I guess we went through this already because everyone talked about themselves. I want to know what you're looking for. And I was hoping nobody is here because you have nothing else to do on a Saturday, especially with the weather like that. So what I want to talk about today is this thing, is the workshop is catered for people without a lot of graphics, computer graphics background. And then what I'm trying to do here is I want to map, that the whole thing is because of the project that we worked on with Microsoft, where we're designing game tools for faculty members with no graphics or games background, so that they can start up and running really fast. And that's what motivated all this workshop. And what I want to do today is I want to talk a little bit about the model view controller framework. And then, if you kind of think about that framework and come back, look at the API that Game Studio and XNA framework give us, it's really intuitive. And then you start to be able to program interactive applications really fast. And then based on that, what we do is we're abstracting some more so that we don't have to worry about too much about computer graphics. And then we can start working on interactive applications. So the goal here today is to use, initially in the morning, we'll use some very, very simple two-dimensional application to verify the framework that XNA framework exposed us to, the software architecture XNA framework exposed us to. And then we will see tiny little bit of 3D example. And then in the afternoon, we'll develop a block breaker game together. And my hope is that we can do that in 2 hours. And I've been doing this a couple of times, and now I look at the notes, I thought we can do in like 10 minutes. So I need to be careful and not go too fast. And I have the tendency of speaking really fast, especially when I'm nervous. You guys have to slow me down. And sometimes when I really start, I stop breathing. It can be dangerous, it can be scary. So anyway, so this is what today's tutorial is about. And I want to kind of take us in a summary of we all start from the same place. And to do that, I thought that let's look at one of the very cool things about XNA technology is that it gives you a completely transparent access to programming the Xbox console. And I want to take us in terms of mapping this, developing for a independent console and comparing to experience we have. And let's see if we can put that together. So if we are developing a program for a console like that, what you'll be doing is that you have your source codes, and then you have your gaming console API. So it's just like a collection of library. And typically what you will do is that you will run your program. I feel really stupid actually up there describing this thing to people who actually know a lot about this. I'll do it anyway. And then when you don't think that I'm saying the right thing, tell me, stop me. So anyway, so what we have here is that we develop our source codes that are based on some API. And then before you start running on the device, what you typically do is you run on some kind of simulation, emulation environment on the PC hardware. Right, and then what happened is that I'm justifying why people do XNA, why I get so excited about this thing. After you're done with your development, you look at your Xbox console out there. On top of it, it has some runtime support. And then your problem right now is to load your program onto the console. And typically, that's where the really expensive things come in terms of there's this magical developer kit that you have to apply and get the permission from the manufacturer, and it typically costs a lot of money. And then you can compile your code and run on the device. This is the way we and PS, however many, works. And now, if we take this framework of you have your gaming, you have your source code running on some API in some magical development kit, and then you can run it on the console. We map that over to what we typically do. We all write programs. We all write graphics program, user interface program. There's our program, and the gaming console API. What it is a collection of libraries, typically graphics, audio. There's some probably GUI support, and then we all do that type of programming underneath in our operating system environment. And what happened is that we have our integrated development environment to support our development for that. And then when we are done, we run our program with API runtime support on CPU. And the reason why we're doing this is that there's no conceptual difference when you're developing your software for a device or you're developing it for your CPU. Now, if we think about it that way, then this Magic Developer Kit that you have to pay so much money for is really not nice. And that's exactly what XNA people did for us. In terms of what they have here is that here's our PC hardware, and then we have this side by side, which is very nice. And I realize I can't demo this thing to you today, but I can show you kind of conceptually. Conceptually, it's the same thing. It's kind of cool to see it working, but then I may not be able to show you. That's okay. The thing, though, here is that here's our PC hardware, and there's your Xbox 360 hardware. And then on top of this thing, if we just look at the graphics part, where we'll focus most of our attention on Dave is back there, so I should be very careful when I say this thing. XNA Frameworks graphics is based on DirectX 9. Is that correct? See, typically I can just say that and people go, oh, really? And I say, yeah, I know, but now somebody actually knows this. And XNA framework, what it is this, the terminology is important. I learned this thing. XNA is a brand name. Okay, and then the API that we work with is called XNA framework. I'm learning to say that now. And so what it is a collection of libraries. And then the graphics version of the library is based on DirectX 9. So from here, then we know that if you know DirectX 9, for example, going to XNA framework is not that difficult. In my computer graphics class, for example, I teach DirectX, and students do their projects in XNA. They learn it themselves. So anyway, so XNA framework kind of sit on top of this thing, and it straddles both of the hardware. And very nicely, what happened is that the framework, the API, they give you the API with a IDE. So that's what they call XNA Game Studio, and the coolest thing is that this is free. And so based on this environment, what you would do is you would develop your source code, and then when you are done, you can compile your source code and run on the PC. And then what happened is that the exact same source code you can compile and run on the Xbox console. So that's kind of nice. And then suddenly you can compile all your program and run on just that program you write can run on both PC and Xbox, and students really like that. Anything that runs on the game console, it's a game. interactive graphics, it's game. So that's interesting. So what we have here is that the way that they load everything over is that here's your Xbox 360 sitting here, and this is your development environment that's on the PC. You typically run your program on the PC, and when everything works, what you want to do is you want to load everything onto Xbox. And then to ensure security, this is what happens when you want to load things onto Xbox. You have to go on Xbox 360, go load a game called XNA Creators Club. So what this game does is that it can verify who you are, such that security can be maintained. And then when you are ready to download your program onto the Xbox 360, what you will do is you will log on to XNA Creators Club. And then from here, you go over to Xbox Live to verify who you are. So you send them your game tag. They'll verify that you are who you are. So now everyone can download program and run on your console. And then when this is all ready and all that, what you can do is that the game studio will talk to Creators Club and load your program. And you can, after that, then you can run it on Xbox 360. So this is the protocol. So, and we'll go through a little bit of this later on. Our problem right now is that we can't go out to the internet. So if you can't go out to the internet, then you can connect. So that's kind of interesting. If you write your own game for Xbox 360, it will only run when you have internet access. And you can only run, well, this is changing. In the past, you are the only one who can run it. So what happened is that because some of us here without a whole lot of computer graphics background, and what we've done is that we snuck in a layer in between. So if you look at this, is typically your source code sits right on top of the XNA framework. We put in a layer in between there so that if you don't know graphics and you don't want to know graphics, and yet you want to do some kind of graphical programming, programming with interactive things. This is what we can do. And today's block breaker game will be based on this library. There are like 5 functions in the library. And I claim that for 2D interactive type application, that's all you need, like five functions. There's a question back here? Okay, if there's no question, then that's what kind of like overview of everything. So what we're going to do today is that we're going to look at the XNA framework. And this is really elementary stuff. We're going to verify the XNA framework and then verify the software architecture that it's exposing to us. We're going to take advantage of software architecture in developing some very simple 2D application. And then when all those things are verified, so that's what we're going to do for the next maybe half an hour to an hour. And then let's take a coffee break. Coffee break may have to be shorter because we started a little bit late. And then here I'm going to sneak in a little bit 3-dimensional graphics. And these are all very elementary things. If you know 3D graphics, this will be too easy for you. And then after that, let's look a little bit at the library that we'll be working with. And all these things are all available online, and you can have access to them anytime you want. And then let's take a lunch break, and afterwards we will do a block breaker game. And I was showing that game just now in terms of, let me see if this still works. I'll show you. Let's look at the block breaker game later on. The reason why I can't open that, I believe, is because this is on Vista, and everything I did was on XP, so I'm not sure about the compatibility there. In any case, are there any questions with regard to this thing? If we are all okay, then I just want to kind of acknowledge I work on this work that I'm presenting is work done that is funded by Microsoft Research, and a lot of work was started from when we were working on developing a material to teach computer graphics, and that was funded by National Science Foundation. I work with Mike Penny from Cascadia Community College, Ruth Anderson from University of Washington, Seattle, and Becky Reed Rosenberg is from our Teaching Learning Center. She helped access students. And John Nollinger is my funding officer here. Let's get started here. Okay, I think I want to close that. What we want to do here is that I'm going to hold your hand and then start developing something, and then let's look what's going on. Let's look at what's going on. So the first thing we're going to do is that we all have our XNA Game Studio installed, right? We're just going to start that thing, and then what we will do is we will okay. let's build a actual game here. So we are going to start, and the sequence that I'm going through is this thing, okay? If you look at your unzipped material, this is what we have. This is everything we have, and then we are in here, and we're going to go through here and go through each one of the sections. I'm not going to bring up the web page because I don't have enough screen space here. But then what you can do is that I'm going to come to here's the root folder, and I'm going to start this, and then we see that everything we talked about now, this is what we're going to do. Instead of going through the web page with you, I'm just going to go through the hands-on with you, okay? And every time when we go to the next one, I'll let you know. So now we are at 1B. And for 1B, what we will do is that we will just start from scratch. And then this is what we're going to do. We're going to go through the steps for 1B now. And the thing here is that we're going to go through the wizard, and we're going to start a new project. And here, this is the XNA projects, and we can start any of these projects. What I'm going to do here is that I'm going to have a Windows game. I can either have Windows game or Xbox game, and Windows game and Xbox game, the source code are identical. That's the cool thing about all this thing. And I'm just going to start with the Windows game for now. And I'm going to create a subfolder, and then I'm going to call this Simple XNA. And I will put this on the desktop. I'll be very honest with you. This is John's machine, so I don't know what will work, what will not work. So I will create a subfolder. I'm going to go OK, and it's working, and then it's done. I will come out here and go View Solution Explorer, so that I can see all the files. And this, the wizard is cool because it gives you everything. And what we can do now is we can come out here, build the solution. Now I'm building the solution, and then I can run. If you click on this green button, it will run. And then my program is running now. So here's my first XNA program. Right? So this is very nice and everything. But coming from the traditional Unix environment where you create every single line of code, this is really intimidating also. That you click a button and suddenly everything is running. And then what happened is that when you go look at all the files that's created for you, man, it's really confusing. So what we want to do here is let's go figure out what just happened. And what I'm going to do now is I'm going to close this thing, and then I'm going to close the Game Studio Express. Game Studio. The first version is called Game Studio Express. The second version of XNA is called Game Studio. And what I'm going to do here is that I'm going to close everything up and go find my Simple XNA. So this is the folder I just created. And then if we open it up, we're going to see all the. We're going to see that there are all these things that's created. So here is my what is called the solution file. And then inside in the solution file, I can see that there is all this file that has been created for me. And then what we want to do is, when I develop in the new environment, is I want to figure out what every single file is. Otherwise, I won't go forward because it's too scary. If people are, if there's any question, you can stop me. And I realize that for a lot of people, this is probably way too elementary. I wonder how, well, I'll just go through my curriculum. I guess teachers should adapt to students, so I should actually poll students and see if we need to actually go through this. I'm doing fine. Thank you. Oh, this is so. You must be a teacher, so you know what to do when teachers are unsure of themselves. So thank you. So anyway, here is the solution file. If I can view the extensions, John, do you know how to do that? I'm looking at. Wait, I want to look at details. The extension of these files are not shown. This file has a .sln extension. This file right here, it has a .xln extension. It's not showing me, but that's okay. This file says that here is my project. Here is my Windows project. And actually, you can actually look at this file. I'm going to open this file with a text editor. So I'm going to, oh boy. Do I still have access to, I guess I can use Microsoft Word as a text editor. So what I'm going to do now is I'm going to drag this file into Microsoft Word.
So if you go to views, you should be able to change how you see the file setting. Under here, list, details.
Right. I want to see,
Then you should be able to move this bar over.
Sorry.
I don't know. That's too distracting.
That's okay. Oh, if you have a text editor, you can open this with a text editor. Open this file with a text editor. And then what I'm going to do now is that I'm looking for, can I run Notepad here? Ah, there we go. So what I started, this is a text editor. I'm just going to drag this file over into Notepad. And then we see that this solution file, this file called simpleXNA.sln file, is actually a text file. Okay, it's a text file, and then when you look at the text file, then suddenly it's not as scary. At least when I see text, I feel more reassured. And what we can see here is that it actually describes how to build the project for us in this text file. And we can see that, for example, now we know this Windows Game 2, this Windows Games 2 makes sense now, because that's what it is. And then we also know that under Windows Games 2, there's something that we want to look at. It's called Windows Games 2, and then there is a Windows Games 2.cs proj file. So the solution file describes how to build projects, and this Windows Games 2 CS proj file is the actual project file. And we can actually look at that also. So I can come into this folder, and then, oh, here's the project file. And in the same way, I can drag this file into a text editor, and then we see that that is also a text file. Okay, that is a text file that describes to you what is the content of that project. And we come in here, and most of this thing looks really scary. There are things that it's a little bit less scary. Things like games1.cs, game1.cs, program.cs, game.ico, and all these things. If you come and look into the IDE, it's all there. Those guys are all here. So what happened is that CS proj file describes what's in the project, and then that file that we just saw is actually this guy right here. Okay, so now I feel a little bit more reassured of what's going on in terms of how things are done. So this is a really sophisticated make file that has been generated for me automatically. So that's kind of nice. And then we come out here, and then we look at all these files. The wizard, we created a folder called simpleXNA. The wizard created this solution file. We examined that in great detail, and that didn't scare us too much anymore. And then we come in and look at Windows Game 2, and then in this folder, we know this file now. We know this one file. We know what this is. And if you have not worked with C# before, anything that ends with a .cs is the source file. So there are two source files here. That's not too scary. There are two things here. And then there's a property folder, object, content, and bin. Now we know that, I'm telling you that object is created by the IDE. It contains the compiled object code. So we can actually delete this. The reason why I like to do this is because I like to delete files. So we can actually select this guy and just delete it. Okay, how do I delete something? We can delete that. The bin and then the object, these guys are generated by the compiler. That's kind of nice. So then we have less files to worry about now. We will look at the source code. Source code we're okay with. Source we can deal with. Just the rest of the supporting thing that really worries us. So I'm telling you now, for example, this file right here, game, if you look at the extension, it's actually called game.ico. And this file is for this. I'm going to come out here now, and I'm recompiling and rerunning. So I just type Shift F5, and that's what happened. That game.ico file is this guy right here. Okay, so you can change that. You can create any ICO file you want and put it there, and then you will get a different icon. So we'll see how these connections are made. Now we just want to know what every file is for. And then we see a file here called game thumbnail.png. What that file is for Xbox 360. When you compile your game and run on the Xbox 360 console, this file, this is an image file. What that image will do is that it will become your game icon on the Xbox 360. Okay, so that's what these things are. And then you can change those things if you want. And then let's see. So we know what this game thumbnail game, this is an ICO file. We know what this is. Oh, by the way, we see object and bin come back now. And then we can see that under property, there's a file called assemblyinfo.cs. That's another source file. So what happened is that when you click on that wizard, you have 3 source files created automatically for you. We're going to look at every one of them. 2 image files. One of them for the runtime, Windows runtime icon. One of them for the Xbox 360 runtime icon. So we know all those things now. And then let's see if there's anything. Oh, there's one more thing that's called this content. Inside content, we'll see a bin, we'll see an object. And then we will examine content in great detail in next tutorial. What this is a description. What content is anything that's not source. Well, my definition anyway. So I used to be able to say these things and feel really comfortable with myself. I can't do that here. These are the media content of your program, things like audio, things like texture, things like, what else are there? Audio, texture, font. Those things are all come under content, and we'll see how those things work. So we kind of know what everything are right now. The thing that and if you look at this thing, here's the property folder. Oh, by the way, what we're seeing here is a one-to-one mapping to the file system, which is kind of interesting. I learned this from Sixi. I think if you click on this button right here, it will show you all the files. Right, this button, the middle button. If you click on it, it shows you all the files. So what happened is that this is a mapping of the file system. This is very different from Visual Studio. If you work with Visual Studio 2005, what you're seeing here is a conceptual mapping of the solution. It doesn't link to the file system itself. What that means is that in Visual Studio, when you see a source file here, you don't know where that source file is. In Visual Studio, what that is a conceptual link that shows you can double click on that and edit the source, where the source file can be anywhere in your file system. In C#, under C#, those files are actually on the file system, and you can actually look at this as a explorer, And let's hide the files we don't need. So I'm just going to hide the files we don't need. So now this is a conceptual view of what we have. But then in our mind, we know this is a one-to-one corresponds to the actual file system. Then we look at this thing. This is a file system, and then this property is actually indeed the folder property. Underneath it, we can see the assemblyinfo.cs. So one-to-one mapping, great. References, this is which are the libraries you will use to compile your system. And I think that this is where the wizard is the most important, because typically we don't know what the libraries we want, and there are like hundreds and hundreds of them out there. So don't delete anything in here if you don't know what you're doing. And under content, we can see that this is a separate project. We'll look at this a little bit more. So we're kind of a little bit better now. And then let's look at the source code. We have 3 source files: program.cs, game1.cs, and assemblyinfo.cs. And if you look at program.cs, this is like your Java's static main. Look, this is a static class program. This is the dummy container. What you do is that you have a static main, so that the loader knows how to load your program. And then when you start, you create a new game class. When the new game class quits, your program quits. So the only thing that's interesting is new game. And this is a file that you typically never change. If you want to hang some global variable out here, you can do that. But global variable is bad. So we typically don't do anything here. So then the only thing that's interesting is game 1. And then we are going to look at game 1. Before we go there, let's look at assembly info and see what this is. And then we can see that assembly info in here, we see that, assembly title, assembly product, blah, blah, blah. Some of these things we don't know. This is the unique identification for the program. So that's kind of nice. Every program has a unique name. And then this guy right here, we can change this. Simple XNA. So this is assembly info. If you change that, recompile and run, and then we see that, the title bar change. The title bar change. Oh, so we know that that's what it is. Okay, so it tells you what are the, this tells you the title bar, assembly product, and description. I think if you put your mouse beside the executable, it will show you everything in the description here. So these are things that you want the system to hint you. And so we have the assembly done, and I'm going to double click on the property here to show us. I just double click on the property. And what we're seeing here is we're interpreting the project file. And one of the things that we can see here is that, see that icon, game.ico. So this is how you communicate to the system what your icon should be. And then game thumbnail. And this is the one that they will use on Xbox 360. So now we look at this and go, okay, we know what's going on everywhere. Well, not really. You know, there's all these build things. I typically don't go there. It's pretty intimidating. But then at this point, we are more comfortable to start. Are there any questions now? So now we kind of know the environment we're working in, and we can actually start look at how to code in this environment. So I'm going to come out here and double-click game1.cs, and in game1.cs, I'm going to close all the functions and just look at the structure. And this is a brilliant way to provide to us the software architecture behind the thinking of the software designers. So what I've done here is I close everything. And here we're seeing a very nice structure in terms of we're seeing that here's my class, and then the class gave me, so these are the functions that I should override from the XNA framework game. So all the application developed in XNA, they're all subclass from this class. And then we can look at this thing. We see that there's a constructor, there's initialize, there's load content, unload content, update, and draw. These are all the functions they give us. And then in doing so, what they've done is that, John, I'm running out of juice. John left. I don't think, so I have 9 minutes left. Yeah, it's plugged in. This is his power supply. It's bigger than my head. Okay, thanks. So the architecture, what they're trying to expose to us is the model view controller architecture. But then we can look at this thing, and here's the calling sequence. When game one first got created, the constructor is called. We all know that, no problem. In a large system like this, in where there are a lot of data structure that's involved, the understanding is this thing. They're going to call game one, and you will allocate memory. After you're done allocating, some of the memory you allocate actually belongs to XNA frameworks, actually inside the system. So the idea here is that they will call you, you allocate all the memory, don't do any initialization there. Because they will, based on what you have allocated, they will also allocate companion memory. And then they will call you later on to do initialization. So what you should do is, in game, allocate memory, initialization. This is the time when you can initialize everything. After you're done initializing everything, they will call you to load your content. This is the time you will load your image, you load your audio and all that. And then when this is done, afterwards, then we go into this very nice sequence of non-stop calling. They will continuously call update and draw, basically as fast as they can. Okay? I think they guarantee calling draw maybe like once 60 times in every second. They guarantee something like that. What I'm trying to say is that there's no guarantee one update, one draw. There's no such guarantee. So you may have, say, 5 updates before a draw is called. It's very interesting. They just call update as fast as they can. So the inside architecture is doing that for you. Okay? Now, based on this framework that they exposed to us, it becomes very convenient to write interactive application. The only thing that we need to be very careful with is that update is meant for you to update. Don't ever draw anything in update. And then when you come to draw, don't change anything. Only draw. It's very difficult to maintain to maintain that discipline because, you know, in update, if you're updating something you want to draw, you really want to draw it, don't do that. Okay, anything you want to draw should be an instance variable, and you should draw it in the draw function. That's all. Now, then what can we do now? So what we can do now here is that based on this, let's create a something that's slightly more interesting. What we have here is really boring, right? We have a blue screen. Well, sort of. But then what we can do is we can do something slightly more interesting. Are there any questions on this thing at this point? So what we've gone through so far is 1B. What we've done is that we've looked at this. So this is what we've done. We went through this thing and then look at everything. So everything I said is described in there. You can look at that. And then I'm going to come back here. And the next thing we're going to do is we'll look at how we can draw with XNA. Okay? And then we will look at how we can draw with XNA. It's painfully slow if you know this stuff. Otherwise, I hope I don't feel like I'm very engaging. I feel like I'm saying things so you guys are entertaining me. And so we're going to draw, and then after that we'll look at interactive control, and then we'll see how we can actually run everything we've done on the Xbox 360. So we're going to go to 1C now, and 1C is based on the source code we have so far. So I'm just going to continue and start building from there. By the way, I want to acknowledge Mitch Walker, because my initial lecture notes in 6C, for example, I don't think it's as good as what he said in my talk, like Dave is doing there. After the talk, he told me like, oh, you really confuse people. I say, I don't think so. He said, let me show you how. And then I look at his, I go, wow, maybe he should offer their lecture instead of I do. So anyway, so what we're going to do now is we're going to come out here and let's try to draw something. Okay, and if you look at your 1C, we're at C now. If you look at 1C, there's a folder in here called useful files, and inside useful files there is a very useful file called ms.jpg. It's an image file. So what we're going to do now is we're going to use that as our graphics, and then we're going to draw that, and then we're going to see how we can control that. Okay, so we're going to draw that file. So this is under 1C useful file. That's not a big deal. We're going to. So what we have here, what I'm trying to describe to you is the fact that there is a resource, there is an image. Image is a resource out on the file system, and here's my program. And when my program wants to use that resource, what I need to do is I need to inform the IDE. I need to inform the system. And then the way I will inform the system, I'm going to come back here now into my IDE. This is exactly where we were just now. I'm going to come back here. Oh, by the way, you can. I need to stop doing. You can change these names, right? What I did is, look, I click on this thing, I type F2. It works exactly the same way as Windows Explorer. Underneath this, is this an Explorer app? Underneath this thing? Is this an Explorer? I mean, there's got to be a way for you to just use it, right? So what I'm going to change this to simple XNA so that it agrees with it agrees with the lecture notes. And then the cool thing is that if you look at this thing, what happened is that I didn't change the folder name, okay. But then I did change the name out here. So that's the project file name. I changed that into simple XNA. Oh, look, I have my extension there. Showed up. Okay, so what we're going to do now is we're going to include the resource we saw just now, the image file. We have to include that into our project, and then we can use it. And then the reason why you need to go through this very complicated process of including all resources into a project is because when you want to run on a separate device, the IDE needs to know what are the resources you are working with so that it can deploy it. You know, think about it. The image file right now is on this laptop. If I want to run everything on my Xbox 360, what I need to do is pick up everything that's relevant on my laptop and send it over to Xbox 360. Because of this process, you need to go through this very elaborate thing of telling the IDE what are the files that are relevant. So we're going to come out here, and this is where we're going to come to content. I'm going to come to content because I'm going to add content into my system now. I'm going to right mouse button click, add an existing item. So I click on content, right mouse button click, add existing item. So this item can be anywhere on your system, okay? So I'm going to click on that, and then what it does is going to bring up a browser for me. And by default, you know, it rests on the on your current folder, and this current folder is underneath my Windows Game 2 content. So I need to go up a couple of folders. I'm going to go up 1, go up 2, go up 3, and then I'm going to come here. and it's under 1C useful files. There's my MS. Any JPEG file will do. Any JPEG, PNG, GIF file, any of those files will do for what we're going to do here. So I'm going to select this file and go add. At this point, I can see that this file is added to my project. Okay, and then remember, because what we're seeing here is a reflection of the file system. So what actually happened is that the IDE actually copied that file over for you. So if you come out here and look at under content, this file is there. Okay, so when you include a resource into the IDE, it actually copies the file for you. And this is rather important because later on when we work with audio, the IDE is not smart enough and find all the audio files for you. So at that point, what you need to do is you need to do the copying yourself into the file system, and then we will see. So we need to know that some of these things are happening behind our back. So fine, the file is copied over. Now we need to use this file. We need to use this image. So what I'm going to do now is I'm going to come out here and in my instance variable, I'm going to add in an instance variable, and all this code is developed by Mitch Walker, by the way. And I'm going to call this sprite, not developed. He showed me how to do this. So what in my mind is that texture 2D texture is a computer graphics way of saying images. So I'm going to associate this image with this variable. That's what's in my mind. And then I'm going to control this. I'm going to show this variable. Okay? So now I have that. And then remembering that I can load this stuff. So I'm going to come out into load content at load content time. What I will do is I will load it. And so I'm going to say my sprite. See that? When I type SP, the IDE gets this thing for me. At this point, I can type tab. And then it completes this for me. And this is under load. So I'm going to load that image into my environment now. If you use the tab key too often, you can't work in any other IDE. It's really, really great and painful. Okay, so here is a little bit of black magic here. I'm going to say content. I just know that there's something called content, and then I want to load. And then I want to load texture 2D, and I'm going to load MS. So in load content, there's something called content manager. So the reason why we subclass from framework.game is because there's all these resources, all these services that they have set up. If you know what you want to use, then you can get things done really rapidly. And that's what we're doing here. We use content. So this is an instance variable in the superclass. We just use it. We say we want to load, and this is a template function, texture 2D. And MS, notice there's no extension. Okay, and then they do that on purpose. So what happened is that on the PC, we have our JPEG file. When you deploy your images onto the Xbox 360, the deployment process will translate that file into another format so that Xbox 360 can use it very conveniently. So that, on the Xbox 360, I think it's called XNB or something like that. By the way, I think if you know extensions like that, you're a real geek. That differentiates you from a typical geek. So I think the loading will fail. So I think if you type, if your extension here is XNB, let's try that. It will run, but then if you say JPEG here, it will not run. If you say JPEG here, it will not. It will bump because this image is translated. I think if you do XNB here, it will run. I think this will work. But then, by default, you don't need to. And then let's see what happened.
And the thing that's in the double quotes is the name of the asset. You can actually change the name, right? The top thing there is the asset name.
Oh, how about that? Every time I talk to, I want to say every time I teach this tutorial, I learn something. Then I realize there's a conflict there. Good. So let's try that. So this is the asset name. How about that? Let's see if that works. And then, now that this is loaded, my sprite now is defined, then all I need to do is to draw it. So what I can do here is that a little other black magic. What I'm going to do here is I'm going to draw my sprite here. And then to do that, hey, notice they create this thing called sprite batch for us. Let's just use it. So I'm going to come out here and say sprite batch. And notice how fast we can type. Sprite badge dot oh, sorry. I don't want to, I want the variable name. So I'm going to do start badge dot begin, and I'm going to do sprite badge dot draw So here, what you're telling the graphics system is, say, I want to start drawing now, and it needs to do some work before you start drawing. And then here, I want to draw. Hey, look, very nice. Texture 2D. There are 7 ways of drawing sprite. We're going to use this. This is one of the simplest way. The position I want to draw it at, and the color. Okay. So I'm going to have the texture 2D I have is sprite. And then I need to have a position. I'm going to bring this up so we can see it. I need to have a position for this thing. So I'm going to new a vector. This is what we tell our students to not do. And then I'm going to have a color dot white. So I want to draw my sprite. That's my texture 2D. And then I'm creating a new position. This is a vector 2D object located at 200, 200. Whatever that is, and then I'm drawing in white. Yes?
I don't have a content like you have there. Why would that be?
If you don't have a content, what that means is that you are working with XNA 1.
Okay. I didn't know there were 2 versions.
Yes. And then if you're working with XNA 1, it's okay actually. If let me try to think where would you add it? You would just add it into, go to your project.
I did that.
Did that work?
I don't know.
It should work. It should work. So I'm going to finish, complete the code here, and oh man, I'm always using the and then end. So basically, you add 3 lines in here: begin, draw, end, and that should work. Now I do compile, and then I will see my nice Microsoft logo. And then, you compile and run. And I usually type F5. F5 is debug, and then they will just compile and run. And if we made a mistake, it would tell me, oh, look. Exciting, no? Oh, who cares? There's actually something we're learning from this whole thing that we can actually talk about. Do we all see that? Are you guys seeing that? You're seeing that. So what happened is that during lunch, you want to install XNA 2, because after lunch, this will be we can do that after lunch. I mean, during lunchtime. Oh yeah, no, you want to do it during coffee break.
What did the color do?
What's that?
You selected a color?
I will tell you what I think. What I think is, see, I'm a really expert in this area. If you have a JPEG file, what you have is that the entire image will cover the entire area. In fact, we can try, do I have a PNG file? If you have a PNG, I have a PNG file. You have a PNG file, different file format. What it does is it contains transparency. Now, the color, I believe, it says that for the places where it's transparent, what should the color be?
So for the logo, for example, would you see up in white there is transparent?
I think this is a JPEG file.
The JPEG, well, so when you change the color to something other
Let's
than
see
white,
that.
you change color.
Does it really? Yeah. Oh, cool. Oh, is that right? Hey, are you guys going to like believe what I say from now on? It's like I don't know anything.
We're learning from each other, right?
Yeah, isn't that cool? Oh, wow. Hey, how about that? I'm excited. And then let's look at this. The thing that I really want to look at is this thing. It's that under content, I'm going to do a listing by, I want to list by detail. And then in here, if we go into my bin and go into debug, oh, it's not here. It's here. Here is my executable. My executable is located in bin x86 debug, right? And then in here, there's that content folder. And if you go into the content folder and think this is where we will see my image.xmb, you are right. That's the resource name. So you can change the resource name. Wow, I'm so happy to learn that. So the compiler that does this for us, so we can actually delete this thing, or you can double-click this guy to run your program. Instead of starting from the IDE, you can come out here and run it from here. So so this is kind of painful to spend all this time and do so little thing. The thing though we are seeing is that this 200 by 200 are pixel location. So this is interesting. So in graphics programming, we do not want to work in pixel space. Pixel space is nice and cool and all that. However, it's integer, and it tightly coupled your semantic of your application to pixel count. So if you want an application, then you can think of my world is 50 kilometers in radius. You have to think my world is 250 pixels in radius. Then if you run on the Xbox where there's more pixel, you run on the PC where there's less pixel, then suddenly your application don't run anymore because of everything is tied to pixel. So this is nice. This is very easy to see the framework that's provided for us. However, this is a problem. And those things are integer. When you draw with sprite, everything is done in pixel. Okay? So now let's try to control this image. Are there any questions so far? Are we okay? Now, I'm moving on to C now, D. Please.
The 200 you've specified is an integer to the compiler, but if you look at the parameters of vector 2, it actually takes float, so you're converting 200 integer.
Oh, I'm converting 200 double.
200 float.
Yeah,
So.
if you are concerned about efficiency, this is what you should say. It makes quite a big difference actually, because what happened is that the 200 was a double, and then you convert it into float, and then typically you get warnings for that. It's not a good thing. So if we want to control what we're seeing on this image, we are at, in terms of this, we are done with 1C now. This is drawing with XNA. Once again, everything we talk about is detailed there. And then we'll go to interactive control. So let's control this thing. There's not much to control, but then let's see what we can control. The only thing we can control in this is let's try to control where we are drawing. Okay, and then this is a place where you start to think about the model view controller framework in terms of what we have here. We are drawing an object, and this object we're drawing is my model. And then I'm presenting it. Here's the view that I'm presenting it. And then whenever you're presenting something for your user, you have an internal representation, and this guy right there, that's my model. And if I want to modify my model, I gotta have a representation for it. I got to have representation for what I want to show the user. And here what I can do is, for example, I can change the sprite to a different texture. And if I want to draw my sprite at different places, I got to have an internal representation for it. So what I'm going to have now is I'm going to come up here and create an internal representation for the position of my sprite. And what I will do is I will create a vector 2. And I'm going to just call it position pos. Okay? So this, right now, my model becomes slightly more complicated now, and it's a position with a 2D texture. So this is my 2D texture. Here's my position. That's my model. For position, it's a variable. I need to allocate memory for it, and I'm going to do this in my initialization. So here, what I'm going to do is I'm going to allocate memory. This is just like Java in terms of everything must be initialized with memory allocation. On the PC. Dave is not here. On the PC, if you don't allocate memory, it will let you run. On the Xbox, it will crash. It's very interesting. There are some of these inconsistencies. So I'm going to allocate memory. It's a good, yes. Hey, Dave. So the vector 2, on the PC, you don't need to allocate memory. On the Xbox, it complains.
Sure.
It's not a big deal, but that's just something that. So what happened is that the students are done with their project and then they go, oh, this is working, and then when they want to last 10 minutes submit it with a deadline, they run into a lot of these things, and I told them it's their problem, but I thought it was interesting. So anyway, so here I'm going to allocate and initialize my initialize memory for it, and then so after I've allocated and initialized the memory, so this is done in initialization, and then when I'm drawing, instead of doing this really ugly recreating things, I just use my position, and I should be careful and make sure that I don't force data conversion at runtime. Okay. And if you run this thing, it's going to work. Just it's going to work. It's fine. Are we okay so far? So whenever we have an actual representation for anything we have, then we can change it. So what we can do right now is at update. Suddenly we can change this position, and not being very creative, let's just put a gravity on there. Well, not a gravity, let's put a downward velocity. So in update, remember this is what happened. Remember the protocol that we derived for ourselves in terms of, not derived, that this presented for us is that initialize is called, we allocate memory. The reason why we're not doing anything in the constructor is because we're not doing anything too substantial. Initialize, we allocate our memory, and load content, we load in the texture, and then from that point on, unload is called when your process exits. So let's not worry about that now. So here we are just switching update, draw, update, draw. In update, we're not doing anything. Now what we can do is in update, we can suddenly, we can update things. And there are things for us to update now. So I'm going to open up update. And in update, what I'm going to do now here is that I'm going to do position.y minus equal to minus, just minus, how about that? Then we can see the effect of the fact that these guys are just continuously sequencing. It's minus, minus. And so we can run this thing and then see my, Why is it going up? Yeah. Traditionally, I understand why they do that. That this in screen coordinate space, y goes up instead of, y goes down instead of up. Y comes from top right corner, goes downward. Right, and shouldn't they change that by now? It's really, really confusing. But I bet you there are a lot of programs out there that depends on that fact, that hardware coordinate is at the top left corner. It's just top right corner. It's just difficult to deal with. But then now we know that's what's going on. So it's nice. So the logo goes up. But then what we can do now is that we can actually come out here, and instead of doing this really boring stuff, how about let's try to control it. So what we can do is you guys have this? If you don't, then you have to watch me play. So, oh, John, do you have the driver for this? You do? Oh, good. If you don't, then none of us can play. No, it's very nice, because what happened here is that I'm going to vector 2, I'm going to define a delta, and then what I'm going to do now is I'm going to poll the gamepad state. And what XNA does for us is that this is very well done in terms of gamepad. Gamepad dot, I'm going to get the state, and player 1, index 1 dot, index 1 thumbstick dot left. So here you can look at, they showed you an example on how do you access the gamepad. So you can have up to 4 of this thing on the Xbox 360, so XNA supports that. And then, this is the left thumbstick, right thumbstick, and then I think these guys are called triggers, and there's buttons out there. Here we can see if you press the button B, you will quit. So what I can do now is I'm going to plug this in so that I can actually play with this. And you guys can watch me. and then we will actually look at how we can installing the driver. Let's see. So let's see if I can actually do that. So what we can do now here is that I'm polling the from the gamepad, and then typically anything that is not that is analog, like this thumbstick is analog. Analog meaning they give you an answer between that's a floating point. It's not a yes or no. Buttons are yes or no answers, 0 or 1. The triggers and then the thumbsticks, these guys are analog. And then anything analog on hardware is typically normalized, meaning that the range is almost always between -1 to +1. So here we're going to get a value between -1 to +1 back. Okay, we are getting the delta here. We're getting from the left thumbstick. Left one is this guy right here, and then this is -1. That's +1. It's just your x and y, and then so this is two-dimensional. And actually, you can press on this thing. And there are all kinds. So -1, +1. I'm going to get those value back, and then what I can do now is I can use that position at equal to delta. So now I can actually move my. Let's see if I can do that. Or I can move my. It's kind of nice. You guys can't. But then no. For those of us who have XNA. Tool, what you can do is I gave you source code for this. So what we are right now is we are at 1D, and if you come to 1D and just go into source code, and start that simple XNA from there. So at every step there's a workable source code for you. So if you're kind of lost, don't worry about it. In terms of it's actually there. And in this version, what I've done is that I did exactly the same thing. Only in the source code, what I do is that I put these things in regions, so that it's easier to see. So you can see that there are regions of code that we have added in. And if you look at this, and we've added code in the what do you call this? In the instance variable area, and then in the constructor we didn't do anything. In initialize, this is where we allocated our vector and assigned it 200, 200. And then I'm going to go down some more. Here is where I load my content. We've seen that before, exactly the same thing. I didn't call this my image because I didn't know I can. Now I do. I should teach this more so I can learn. This is cool. And then here is my update function. And let's look at the last. And then draw is exactly the same thing that we've seen just now. It's just I'm drawing my stuff. And then in the update, what I've done here is something slightly more elaborate. What we're seeing here is I'm polling the thumbstick, the left thumbstick. So that's what I can do. Otherwise, what I can do is that they also provide you with a keyboard interface. So what I'm doing here is that I'm asking myself, is the first player 1 controller connected? If it's connected, I'm going to poll it. If it's not connected, I'm going to do it from keyboard. So the keyboard, you just get a keyboard state, and then you ask the key if the key is down. It's interesting that this API doesn't give you event. There's no way for the API to interrupt your program. This is slightly interesting, different from your typical GUI programming. In typical GUI programming, what you do is that you set up all this callback. You say, if a mouse button is clicked, call this function. And then after that, you go into a wait state. This, you can't do that. This continuously go update, draw, update, draw, update, draw. If an event happened, too bad. You have to go poll that event. So what happened is that XNA reports to you state. It doesn't report to you event. We are very used to when mouse button click, I want to do something. Here, I can only know if the key is either down or it's up. That's very different from what you're used to. So if you're playing a game and you want to see, it's so violent. Can I come up with another example? I can't. You want to plant the seed, very good. If you want to plant the seed with A button, and then you press the A thinking that I'm planting a seed. But then it's post 60 times a second, you planted 60 seed. So if you want to press, if every time you press and press down and release, you want to plant one seed. In your update function, you have to detect that transition. You have to detect current state, and you have to have a previous state, and you have to check that the state changed. So that's very different from your typical GUI programming. This is polling, current state only, okay? It's limited because of the architecture. So anyway, so if you compile this and run, then you can play with what we have just now, with your keyboard. At least I think. Oh, that's because I have my game controller. So I just remove my game controller, and now I can do the same thing. Okay. So what we have done so far is we have basically didn't do anything other than try to verify what we were arguing to ourselves from the beginning, saying that here is the this is actually a software architecture that's reflected for us to work with. How do we take advantage of this thing? And then here we are seeing that we actually initialize things, we know how to load things, and then we see update and draw. We see that in the update, if you have a state that you can change, then in draw you use that state, then you can have a very smooth transition of things, which is nice. So with all this, then we can start thinking about something slightly more complicated. Okay? We're about 5 minutes, 10 minutes after. Are there any questions? The last thing I want to do, which I cannot really do, is to show you how you can load and run on the Xbox 360. And I say I cannot do because I believe what happened is I don't have access to Xbox Live. If I don't have access to Xbox Live, then let's see if you will let me go to Xbox Live. Yeah, it's wire connection. It won't let me go onto.
In Microsoft, we don't allow people access to the Xbox Live.
It's kind of strange, if you have access to Xbox Live at work. What does that mean? Since I've been funded by these guys, it's great. This is a great story to tell. Like this Xbox, I bought it one Sunday morning because school's about to start. We have to use it, so I went to Toys R Us. I bought 4 Xboxes. And the guy was looking at me like, wow, serious partying. And then I saw Xbox Elite. I said, gotta have that. So I'll take that also. What are you doing? And I went home and told my kids that Daddy just went do research. So they saw I bought 5 Xboxes. It's great. And I have one in my office, right? And the janitor, every time coming when they clean, they look at me, it's like, what are you doing? How much are they paying you? The thing, though, is this thing. What you will do is, we can talk about this hypothetically. You will go to Xbox Live, and in there's, if you go into the purchase game, and you will find XNA Creators Club. And you will download XNA, you will download this game. Let me show you.
Just to make a quick comment there. Don't
Please.
forget that for those of you, obviously those of you in faculty, you should be using MSD and AA to get your codes for the game studio for the Creators Club stuff to access the Xbox. And for your students, they can use DreamSpark and they can get a free 12-month code where they can deploy their games on the Xbox 360 as well. So basically, in the academic world, there should not be any exchange of money between yourself and Microsoft in order to be able to deploy and test and debug your games on the Xbox 360.
If you send me an email, I'll show you the instruction. My students are doing that, and it's great because I was getting this card. If you want your student are working on this thing, talk to Microsoft representative. They'll give you a card, and you can sign up for 4 months free. So I have not a stack. I have a few of this card, and I give it to my students. And then they run out of time. They run out of the 4 months, and then they come back to me, and I told them there's this thing you can try, and they are doing this for free now. So it actually works. If you send me an email, I'll show you. My students, I have an instruction on how my students sign up to do this thing. The thing is, here's the Creators Club. What you want is Game Studio Connect. If you run XNA Game Studio Connect, right now it won't let me run because it will try to verify who I am with the Xbox Live. When you can't do that, it won't let me run. Okay, and this is security part. And I think this is also their revenue model. But the thing though is that if you run this Studio Connect. So these are the games that I write. Right now I can't show. Remember this? This is the game thumbnail.png file. That's what we're seeing. So you can change that into anything you want. These are the games I've written. I can't run any of this now because it will try to verify who I am before you let me run this. If you run Studio Connect, there just now. So there's the XNA Game Studio Connect, and on your PC. So I will run that, and when this guy wakes up, it will give you a code. Okay, and then you have to type in that code for your machine, for your PC to communicate to Xbox. And both of these devices must be on the same local net. So on the PC, this is what we can do. On the PC, we have developed everything here. And everything, this is all done for PC. But then what I can do is, if you right mouse button, click on this guy, and there is a create copy of project for Xbox 360. So obviously, a PC project cannot run on Xbox because all the software support and everything, they're all different. However, if you want to do this thing, they will do this automatic translation for you, and this works about 95% of the time. Sometimes you need to go in and hand tweak a little things. I'll show you that later on. So here I'm going to say create copy, and then it's going to warn you that it's not going to do it correct all the time. And there we go. Here I have a project. Isn't that cool? This project, if you look at it, the source code is identical. This game1.cs is the same source as this. If I double click on this, it's going to complain saying that this file is opened by another project because it's opened by this guy up here. So I can close this file and then open it from this project. We can see it's exactly the same file. Now, if I come out here and what I did is right mouse button click and debug and start new instance. If I just do that, it will ship everything over to Xbox 360 and you will start running on Xbox 360. From that point on, you can debug your program just like you're running on the PC. I can't show you that now. But the only thing that is slightly different is the deployment takes a little bit of time, especially when you have large textures and all that. It's going to copy everything over to Xbox 360. That takes a little bit of time. Yes?
From an instructional academic point of view, is there any benefit to your students actually using an Xbox 360 other than it's cool with Microsoft?
Oh, yes, you see their eyes turn round.
Well, I understand that, but is there a practical benefit at the level you teach?
I think what happened is that we teach this class in a lab. And then students walk into the lab, they see two Xbox 360. When they run into trouble, they look at that, they try. That's what I'm observing. But then typically what happens is that you'll finish your entire coding, like in my computer graphics class. A lot of students do their projects on Xbox 360, but they'll finish everything. Now this is like thousands of lines of code. And then everything's running, and then in the last half an hour, they'll try to just compile it for the Xbox. And sometimes they run into trouble. Yeah.
Well, I have a stupid question then. How does the game controller work with the PC?
So what you will need to do is, that's a really good question, it's not stupid at all. What you will need to do is, oh man, I have a help page for that. I have a help page for that. So we are at E here, Xbox 360, and here I'm showing you exactly how to do this thing. And here is a guide on how you can do this. This will actually bring us online. So Microsoft has a very detailed guide on how you can do what I just described to you. And
but you can connect the controller to a PC.
Yes, but it cannot be a wireless. It got to be a wired one. Can I show you something? I can show you anything I want, but yeah, no. You need to install a driver. I think on the Vista it's probably automatically done. This is our project webpage. So here is the page that we've been looking at. If you go to the very bottom, here I have an acknowledgement to Mitch Walker. It makes this thing flow so much better. But then this is the project that we're working on. And if you're academic type, if you click on this thing, what we have here is that if you come onto this here, there are 7 programming assignments, all based on games. That challenge students to implement your pretty conventional computer science concepts like implementing a binary search tree or implementing a linked list, but then in the front end you see a game. So I'm going to click on that now, and here's a download and installation guide. And then if you come out here, I have very detailed instruction on a whole lot of things. I'm really sorry that I don't have a simple link from today's.
The short answer for the gentleman is you need to make sure you have this thing called X input. And so if you go to Microsoft's download site, X input, I haven't looked lately to see where it really is, but it is called X input. And that's what you need to use the controller.
On Xbox 360 site, they actually have that. And if you look around a little bit, or if you send me an email, yes.
About the driver for the driver. It'll automatically install with Windows XP SP2 or Windows Vista. It's already built into the operating system. Just plug it in and work.
Oh, really? Huh. Okay.
It should work just fine. If not, you can go to the Microsoft.com hardware site. You can actually download a separate driver for
right. That's what I did.
Xbox controller.
Okay.
You have to get the DirectX SDK, and that's really huge. And unless you really need the DirectX SDK, I don't recommend downloading it.
So you don't need the DirectX SDK to use Game Studio? XNA Game Studio?
You do not, no.
It's completely separate, isn't it? So XNA framework and Direct3D are two different things. Cool. I'm kind of done for the first section. I'm done. And if you come back, I will talk about. No, I mean, I don't know how bored you are. If you come back, I will talk about 3D a little bit.
How long a break, Kelvin?
Let's take say 10-minute break. Yeah. How about that? 10 minutes, and we'll come back and do that. And you guys may want to install XNA too. Yeah. Okay. Cool. And.
Say again. Yeah, that'd be great. Okay, so let's get started. I wave to the camera that tells the fellow he needs to sync up. And thank you again for your participation. And thank you, Kelvin, for a great talk.
Oh, thank you. So if it's just your app still installing, it's okay. I have to. I'll stop apologizing. John told me that that I should cover a little bit 3D, and then I started thinking about 3D. And I started thinking about 3D, and I got really scared because I don't know how to talk about 3D without teaching 3D computer graphics class. And if you guys want to learn 3D computer graphics, I can do that right now. We'll be here for the next 2 weeks. I have a real passion for that. I have a real passion for a lot of things. But so what I did was I snuck something into here. This is not linked in from the web page at all because it's so unorganized. I spent quite some time trying to organize this thing, and I kind of did a half decent job, maybe even not decent. So let me just talk a little bit about 3D computer graphics, and let's see that the framework we saw just now, the software framework that's provided for us in three-dimensional world, what it means. So we just look at that very, very slightly. So and that's what I'm going to do now. I'm going to talk to you a little bit about 3D computer graphics, my way of looking at it. Okay. So here is the PowerPoint. There are like 6 or 7 pages in here, and most of the slides from here are taken out from the book that I'm writing, or that I've written. It should come out. I'm holding my breath, waiting. It should come out any day now. So here's a little bit of introduction to 3D computer graphics, and what we've seen just now is two-dimensional graphics, and then because it's two-dimensional, a lot of things are quite intuitive. One thing that's especially important is in two-dimensional computer graphics, your eyes are fixed. You're looking, you want to think about that, you're looking at a plane perpendicularly up, just looking at it, and that's all you have. And because your eye position is fixed, looking at a plane, all you need to worry about, and that's all we worry about, is moving objects. And that really, really simplified the world. So what we're going to do now here is say, when you want to talk about three-dimensional computer graphics, then you have to look at the real world that we are in. And in 3D graphics, everything, all the conceptual models are based on what we're seeing today. And so I'm going to start by looking at something really simple. Here's a photograph. Here's a photograph of 2 pieces of paper. I actually took this photograph, like 2 pieces of paper like that. And then what we're seeing here is that, you know, we can look at this thing, and then I put one paper here. I put another. Oh, I can show you how I did this. We need to worry about the papers, the size of the paper. And in 2D graphics, that's all we worry about. We don't worry about anything else. We worry about the image we want to draw, how big it is, where it is. That's the paper, the size of paper. In computer graphics, we call this the model. And then it maps quite well, conceptually to model view controller's model. That is our model. So in 3D graphics, when you want to generate an image, first thing you worry about is the model itself, the geometric model. Here I say there are two pieces of paper, the size and the arrangement, where are they? And then you look at the real world, you look at imaging system in the real world, then you realize that you always have to worry about a camera. You always have to worry about a camera in terms of where's the camera and the orientation of the camera. So, like what I'm going to do now, I have two pieces of paper there, and then I'm going to point my camera at it and take a picture. The location of the camera then becomes very important. Okay? And then finally, the lighting. If you switch off all the light, I shouldn't see anything. You switch on the light, you will see something. So there are three very important components if you want to do 3D computer graphics. And each one of them are quite complicated. And in a 8-hour lecture, you can touch on each one of them slightly. And in the next 8 minutes, I'll touch on the top two slightly. And let's see how kind of job I can do. No, in terms of, this is the setup I have when I took those picture of those two pieces of paper. I actually went and measured it. They're 8 cm by 8 cm, 5 cm, and then here is my camera is like 25 cm. Why am I doing all this thing? I'm doing all this to convince myself and to convince the reader, I hope, that anything you can see with your eyes, if you can describe the geometry of it, the description, the geometric description of this piece of paper can be difficult. They are paper, so they're relatively easy. We map this directly to a square, so that's kind of nice. And here's my camera. And if I have all this distance relationship ironed out, then all I need to do is describe this to the computer. If I can describe this to the computer, then 3D graphics is trivial. Well, until you want to move the camera, then you actually have to understand the math. So mathematicians look at this and go, piece of cake. We do this, we map to this structure, we say piece of cake, and then when we look at the math, we go, ooh, let me do something else. So what, with this arrangement, then how do I actually code this in? Well, then we need to have concepts from computer graphics. And this is what we can see. I start doing measurements. I start defining, if you want to describe things to the computer, you gotta have, geometric description, you gotta have a coordinate system. So here I start defining coordinate system for myself, and the way this is set up, I'm looking at the center of this piece of paper, and if this is the center of this piece of paper, then for the large piece of paper, I can start in centimeter units, then the edges, the vertices, you can start looking at the vertices, and then these are the values for the vertices. And then in computer graphics, that's what you actually do. You will go and you put your model together, independent of where you're going to view it, and you start measuring everything, and you start figuring out all the vertex coordinate, vertex position and everything. Large piece of paper, small piece of paper, and then my camera is out here, somewhere out here, somewhere up here, and looking down toward the center of the point. This location right here, this is the location. Camera position, and by measurement my camera position is located there, and I'm looking the camera. When you have a camera, your camera is looking toward a point. I'm looking toward the origin, so the local position is the origin of my world. So now I've measured everything, I derived everything, and one more thing is that this camera thing, you can have portrait or landscape. So there is kind of a sense of up. What do you want the up to be? Okay, so you need to describe the camera position, you need to describe your geometry, and one more thing is that's because of the mathematics. We have to define a viewing volume, the visible volume. So what happened here is that my camera is here, I'm looking in this direction. My eyes implicitly define a visible volume. I have a field of view of about 180 degrees. This is all I can see. So this is the volume I can see. Now, when we want to describe this to a computer, for your camera, for example, this has a field of view of maybe 22 degrees. So we need to actually define how big a view I can see. Okay, and then other things, you need to define how close you want this thing to be. So we need to bound things because computers are so the representation, there's limitation with representation. So I'm going to define a volume like this thing. I'm looking in this direction, maybe about 30 degrees, and then I'm going to bound my volume. So everything in this volume I'm going to see as an image right here. So that's kind of the consumption model of this thing. How do we implement something like this thing? That's all. So the thing, though, is that everything we've described, we can code. And what Graphics API does for us is it gives us the tools to do exactly what we want to do here. And you guys need to remember the numbers because I don't. But then I'm going to show you the code. So this is the PowerPoint slide that we just saw, and then I'm going to come out here and show you the code to implement what we saw just now. And if you this is in here sneaking 3D examples B. There's no link to it because I don't know how to link to it. It's short of writing another book right here. So I just opened up this simple example, simple XNA here, and this is just pure and simple XNA. And then when you run it, that's what we were seeing in terms of 2 pieces of paper, camera position, right? Now, if you faithfully try to describe what you're seeing to the graphics API, it gives you something pretty accurate. It's approximation of actual physics. And then it's very nice that the actual API looks like our mental picture in terms of, I'm going to look at the code now. So in here, we're seeing that, you guys can stop me anytime you want to if you have any question or anything. Here we're seeing exactly the same source code structure, so nothing is new here. And everything, all the actions are going on in game1.cs. I'm going to open up this file, and it looks really, 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 really scary. And the way to do this thing is to close up all the things that's scaring us, and then we can look at the basic structure, and then it will make some sense. So what I'm doing here is I'm closing up all the things that's scaring me, and then if there's no detail, then it's not scary. Hey, look, it's identical. It's easy. Okay, so it's a little bit easy, but then let's look at this thing. For a camera, I need to actually faithfully reproduce what I was measuring. So I have a camera position. I'm looking at 0, 0, 0. My camera position is at 0, Y is 10, and then Z is negative 25. So I have a coordinate system. I just did that. Okay, so I have a camera position for that. And then what I'm going to do now is that I'm going to use my camera position to draw myself a picture. And now I have to, I'm debating how much depth I should go into. When in doubt, always provide more detail. Sorry. So can we all see on this side of the board? The simplest conceptual framework looks like this thing, and Direct3D provided us with this. We all started with the OpenGL, and Direct3D improved upon that. So we can think of computer graphics as a pipe, okay? And then in this pipe, what we have is we have 3 matrix processors. This is the most traditional. This is called a traditional graphics pipeline. And the reason work on shader, on vertex shader, on pixel shader, blow all these things away. As we understand how the pipeline works, we realize we don't need to follow the pipeline at all. But then this is a very convenient way of doing that. And what we're doing is that each one of these guys has a name. This is the world. Each one of these is a matrix processor. A matrix is capable of multiplying with a vertex position. Okay, so here I have a world matrix, there's a view matrix, there's a projection matrix. And my vertex comes in and gets transformed in subsequent order. So based on this very low-level abstraction, what we can do is we map the camera onto this guy. This is the camera. And this guy right here is called projection. This is the visible volume. And this is reserved for the model. So what we're going to do now is we're going to program this matrix processor and program this matrix processor. The math behind this thing we're not going to go into, but then the camera, we can, based on this field position, we can put the camera information into this matrix processor. We'll get the visible volume information into this matrix processor, and then we can just do what we want to do. So by programming these two things, what I'm doing is I'm placing my camera at the position where I want to place and looking at the world like I want to look at. So let's look at draw. Draw is slightly intimidating. I'm going to open it up now. And the reason why I don't want to talk about this thing, or why I don't talk about this in tutorials like this, is I really don't know how. Let me show you what's initialized. It's if you come here and try to understand what all those things are, it's just not cool. So here, I'm going to look at my draw. In my draw, I am clearing my graphics device to light gray, so that we kind of understand. This next line of code, we really don't want to know what that is. And then in here, I start doing something. But then one thing we do notice is that there is a world matrix processor. I set it to identity, so I'm initializing my matrix processors. And then after that, I'm going to define my camera. I'm going to define my visible volume. I'm going to define my two pieces of paper. I'm going to draw the look at position so so we know what's going on. So I'm going to define the camera. I'm going to define the visible volume, and this is how I define the camera. I define the camera by coming out here and say my view. That's my center matrix processor. My view gets. I want to create a matrix, and what this matrix will do is conceptually it will place my camera at the right place. So this matrix accepts three parameters. It accepts look at, the camera position, look at, and up vector. So that three parameter place my camera at the right place, at the right position, looking at the right position, and the last parameter up vector orientate my camera so that I can do landscape or I can do a portrait landscape. So that I have loaded my center matrix, and then what I'm going to do now is I'm going to come out here and define my visible volume. Once again, it's relatively straightforward. I call a function to do that for me. And here, I have a 60-degree field of view camera and aspect ratio of the screen. This is like the film you have, 35 millimeter versus whatever you have. And then this is the near and the far clipping plane, near and far. So that defines a volume for myself. So this defines a volume, and the volume comes in the form of a 4x4 matrix. If you look at this slightly, and it really gives me goosebumps. It's like, wow, math is powerful. I'm sure glad I understand this stuff. And then, so we're done. So what I have so far is I've set up myself for this environment. Here's my camera of this volume. Whatever I put into that coordinate system, I will see. Okay, what's in that coordinate system? I have like a big piece of paper, a small piece of paper, 8x8 paper, 4x4 paper. And if you memorize the vertex position we've seen just now, we're going to see here again. So what I'm going to do now, look at the code. It's really ugly now. I have 4 vertex position because I want to define 2 polygons of 4 vertices each. The first one, this is my large piece of paper. If you remember the vertex position we've identified for ourselves, everything is done in centimeter here. The second piece of paper is smaller, and the vertex position are such. I'm going to draw the first piece of paper, this 4 vertex, as a triangle fan. Let's not worry about what that is. It's just basically a couple of triangles, 2 triangles using these vertex positions. Okay? There'll be a quiz afterwards. No, I hope this is just for fun. I have a lot of passion for this stuff. So when John said, can you do 3D? I go, yeah. How much do you want to know? So anyway, so I have these 2 pieces of paper, and then the point here I'm trying to make is whatever geometry you define here and draw, anything in here you will see, right? So here we're seeing these 2 pieces of paper, and then that's it. So when I run this and draw this thing, we see that 2 pieces of paper. Okay, and the reason why I draw this red dot here in the middle, I draw this middle red dot is to show myself where my camera is looking at. Otherwise, in 3-dimensional world, it gets confused very easily. You guys can compile this and run this. And I will advise you to do that because we can actually do something in terms of let's try to fit what we're seeing here into 3-dimensional, into the model view controller framework that we've been looking at. So I'm going to come out here and close all this. So we know how drawing is done. Right? If we know how drawing is done, then we go like, okay, so I can draw things. And then if we map this back into what we were thinking earlier, what we were understanding earlier on, is that if I have my model, and in my model right now, my model includes those 2 pieces of paper, it also includes the camera. Those are all my model because that let me see what I'm seeing. Then in my update, I can change those. Change those like what? Like for example, if you notice my camera position and look at position are instance variables. So I have my camera position. I'm looking at position. I can actually change my camera position. And a lot of times when we look at things and the movement we go through, we don't know what we're doing. Okay, I don't know what I'm doing. Maybe you do. So if I'm looking at my cup and I want to look at it more carefully, what you do is like if that's a big car, is you will orbit it. You orbit. You don't like. In code, it's so much easier to do translation. See that? It's so much easier to do because I'm just changing my x position. If I want to orbit this thing, it's actually pretty tricky because what I need to do is I need to make sure that when you orbit something, your eye position, this is like a fixed distance from that point, and I'm orbiting, and I'm looking down this direction. And if you think about the math, it's not that difficult, but then to implement something like that, it's not just call a function, you're done. Well, if you implement a function, then that's what you do. But then the math can get a little bit hairy. But so let's not do that. Let's just do this. I'm going to come out here, and then when I want to move my eye position, I will just do this in X and in Y, and then I'm going to move forward and backward. And the result is just bizarre. And let's see that. So you can run this yourself also. I'm going to run this again now. And you've used the arrow keys. I'm moving my camera position left and right. And then I'm moving forward, backward. Okay, these are things that we don't typically do. And then when this happens, it just looks bizarre. And then if you use the JK and I key, if you use VI, you know these keys. JK, I, and L, you can move the look at position. Okay? Now, what's the point about this thing? The point about this thing is that the framework we kind of understood from the first hour of today's workshop in terms of update, draw, update, draw, update, draw, works whatever. If you want to work in 3D, fine. You want to work in 2D, fine. It's exactly the same thing. And any instance variable you have that you use to draw, you can change the appearance of your image. Now, if you know some mathematics, what you can do now is you can write your update function. You can just twirl around this and then kind of zoom in into a point. You can definitely do that. So if you look at the code of what we're doing, is that I'm not lying to you. In the update, set camera position. Look at that. So if the game is connected, I'm going to go through this. Well, let's just look at game. If the connection is, if the game controller is connected. If the game controller is connected, then we'll come into here, and then we can see that I'm going to get the left and right thumbstick and use a position and use that to update my position, change my positions. And then you can actually move up and down also using the trigger. And then I'm going to get those values and use them to change my camera position and look at position. So indeed, I'm doing that. Okay, and then you generate this very sensation of like you're flying around. And then if you hook this position up to a function, then you're flying. Then if you have a good function. So, nothing spectacular here. Are we okay with this thing? Yes, okay, we're okay. And then I want to show you one more thing because, if we talk about graphics and I only show you 2 pieces of polygon, you want your money back. So I have to show you something slightly more respectable. And I'm going to show you a tiger and a plane. I think I just compiled. Oh. A tiger in a plane. Okay? So, and then if you look at the code, it's, big deal. Well, it may be slightly interesting. In terms of in content, look, I have a swishy, that's the plane, and then I have tiger. So these are mesh files. So I say that the geometry of something like my phone is really complicated. I do, but then you don't really want to know how to define the geometry of this, right? It's really scary. So what happens is that artists spend like half of their life define one phone, and then we can display it out here. So, and then all we do is that we import that a mesh file. A mesh file is basically a collection of triangles, and then we can draw it. And then, so what we can do now is once again we see that everything we've seen really generalized in terms of concepts. So I'm going to come out here and I'm going to close this guy up. That's just scary. And then here we see that I have a model that's called tiger. I have a model that's called craft. And then what I have is that in initialize, I didn't do in load. In load, remember load just now what we did was we loaded the texture file. Now I can load the tiger, I can load the sushi. So these are data structures out on the file system. I load them into my executable, and then I can draw them. So after they are loaded, then we can come with I never unload anything. Well, and then I don't update these guys either. But then what we can do is at drawing time, what we can do is define my camera, define my visible volume, draw the 2 pieces of paper, and then draw the tiger. Draw the tiger. Draw mesh tiger. That's my tiger. My tiger is a variable that points to the data structure. That's the tiger mesh. And I draw my craft. I draw my craft. Here we start to see things that start to get rather involved. I'm changing my world matrix. I'm changing the orientation of the tiger. I'm also changing the orientation of my craft, and I'm moving them around. So when it comes to 3D graphics, now you can start thinking that these numbers right here, if I make them into instance variable and update them in update, then I can fly my tiger. And if you know the mathematical functions for flying, then your tiger will fly around very well. So in a lot of sense, when you learn 3D computer graphics, it's all applied linear algebra. Mathematicians look at this and they laugh, go like, huh? That's what you do? Then they felt cheated because, we do have a mathematician here, she shut up. The draw mesh function is slightly involved, but that's not very interesting because we really don't care. In terms of a conceptual framework, everything we've seen works. We okay with this thing? So that's my 2 minutes of 3D graphics. Yes?
Just a question maybe for some of the Microsoft people.
Sure.
The DirectX models, have there been any incompatibilities between old .x files and the latest 2.0 XNA stuff? Or can you import, is it just trivially simple? I've had some troubles importing old .x files and I'm not sure why.
David's there.
.x format is not rigorous format. It is not a standard. It was done about 10 years ago in order to create a model format that people could, that standard programmers could use without having to buy really high-end DCC, tools like Max or Maya or something like that. It was never intended to really be used in the way it's being used now, and which is why, by the way, that as like in the March, the latest SDK, the latest DirectX SDK, there's a lot of deprecation about the .x stuff. The .x stuff libraries will continue to exist as they are, but there probably won't be any more improvement to them. So if things don't work, you may want to just go back to a model tool and re-export the model use a different type of model tool to re-export it to the .x format, or look at the documentation and see how you can kind of twiddle with it.
Well, bearing in mind this is being recorded, we can take this question later, but what's the preferred format these days for XNA modeling?
Well, for XNA, we have a complete content pipeline that supports any type of format. You can write your own content pipeline importer if you want to.
Well, you can.
We support out of the box, we have .x and .fbx formats that are supported. You can find other content pipeline importers as well, like Colada, for instance. So we support .x and FBX out of the box.
FBX, did you say?
FBX is a Flashbox format that was created by Autodesk. It's kind of an open format. They control the API and they control the layout of it, but they make it available for anybody to use. So most modeling tools will export into that format if you want. So if you have a modeling tool, you can pretty easily export to FBX format.
A question to the lecturer then. What formats do you use in your classes to develop your models? How do you
I teach interaction. I don't teach modeling, not that much. We talk about script and all that. But then I try to shy away from standards, and I provide them with example on how to use .x. So when you were asking him, I wrote it down because I really care what's the next one. But students try to do something. I don't know what they do. So they go import this stuff. Well, it's data format translation, and I don't want to get involved with that.
So just to clarify, we have more and more modeling companies that are starting to kind of come onto the bandwagon for supporting XNA Game Studio stuff.
Right.
Softimage is a great example.
Right.
Softimage XSI mod tool actually has content pipeline integration built into it, so that as you build whatever that model is, it gets brought into the content pipeline importer automatically. So we expect to see that changing as time goes along, that there will be more and more modeling companies that will support that.
I guess my question was, as an educator, I was wondering if other educators could provide any insight as to how they're getting their students to do the modeling in a simple way and pull the stuff into XNA. Or maybe the answer is no, so we should probably move on.
I find .x is sufficient for not sophisticated. For example, we don't do animation, so if you do animation, then you have to be a bit more concerned with this. Please.
I've worked with a lot of schools that have been doing this, and one thing I found that's pretty clever is a lot of the schools are partnering with the art departments,
Right.
so that they have the kids in the art department that have, the software packages and expertise.
So they're using Maya or something.
That's right, but in the art school, and then they work with the software developers so that they create the art. Software developers don't have to, but they have the models they can take advantage of.
And are they using if they're using Maya, for example, are they using the .x format? Or how do they,
Well, they can use Maya, it's not Maya animations, but the Maya stuff comes in fine.
Okay, thank you.
So we sneak off from our curriculum a little bit, and we'll come back now. And the goal here is to provide us with some background in the next 10 minutes so we can actually go eat lunch. What we want to do then is to, that the framework we've seen just now works really, really well. However, it's also true that if you don't work with graphics a lot, and importing all these things can be a little bit intimidating, and drawing the everything you want to draw in XNA, for example, they're all triangles. So you have to draw them as triangles. And so what we did is we developed a library, a really, really, really simple library for people who do not program games or graphics to use. And here is the documentation for the library, and I think, oh, okay, wow, this works great. So, and I'm not going to go through the documentation of the library because none of us like the documentation. Here I explain, if you go down this page, you will see that in this application that we won't look at, is I demonstrate every single function, in one application, every single function call in the library. And then to do two-dimensional, we're back to 2D now, to do two-dimensional interactive graphics application, especially at more elementary level, all you need is ability to draw a rectangle and draw a circle. And that's all we do. We can draw a rectangle, draw a circle, and we can output text and nothing else. And now then what we have is a really, really basic tool. And then with that basic tool, let's see how we can build something kind of interesting and fun. And that's what we're going to do for the remaining of the workshop. For the next maybe 20 minutes, we'll get a little bit taste of how to work with this library. And then after lunch, let's do the block breaker game. Okay? So this is for you this is your homework. It's due on next Tuesday. That you have to read through this and understand everything. No, you don't have to. We'll look at a lot of this. So what I did here was I skip over 2A, the details of 2A. And this is basically documentation of the library. The documentation is based on one example. So we're going to come and look at working with the library now. And this is 2B. So we will go back to our, I'm going to quit from all this stuff that I've started. And I'm just quitting all this stuff. And then what we'll do now is that we'll come back here, and then we are looking at we're looking at, this is under section 2, XNA library. We're going to come in, and we just skipped the library itself. We're going to look at drawing simple circle with the library. So you guys can come out here and go to unzip the begin template source, and if it's already unzipped, that's what it is. And so we're going to come into begin template source, go into the source file, and start working from there. Okay? So I gave you a template. So this is under 2B, begin template source file. We're going to draw a circle. Unbelievable amount of work to draw a circle. But then investment will pay us back. So if you look at begin template source, if you unzip that zip file, this is what you get. You get begin template source. There's source file folder, and then there's a useful files. And if you look at useful files a little bit, in here there are 3 things, and actually there are 2 things. Just one of the things are in 2 different formats. There is a font file. So in XNA framework, everything you want to use are content, are resources. You have to specify them. So this is the font we will use to draw everything. So at this point, we know that if you want to output text, you got to have this content, and that's what it is. And then these guys right here, this XNA assignment base, these are the libraries that we have developed, and they are in the form of DLLs. So we are going to include these DLLs into our project such that we can use the utility provided by these 2 libraries. What we're going to do now is we are going to, so these are the files under useful files. We're going to go into source code. So here I'm at the source code. Are we okay? My student told me I should stop asking that because when they're not okay, they're not going to tell me. And I thought, hey, it's kind of nice you tell me you're not going to tell me. Why don't you tell me that you're going to tell me and just tell me? They say, we just won't tell you, so stop asking. So we come out here, and then what we have done is that we try to make the entire content, the entire structure similar so that we're not intimidated. And the template that's provided for us, we can open it up. The first thing we see here is there are a huge amount of usings. So these are all the XNA framework libraries. There's the audio, there's the content, and all the libraries. Fine, we're going to hide that. And then if we look at the structure of the program we have here, it's slightly simpler than the XNA framework. If you remember, so far when the wizard gives us a template, it's subclass from the default XNA framework.game. Here we subclass from this thing called XNA assignment base. So this is our library, and we try to simplify things for us. And then when we look at the code itself, there are only 3 functions now. There is the constructor. As we will see, constructor just do one thing. And then there's the initialization, the update, and then the draw. So we took away the load. So that what we are trying to do here is that we load everything transparently for you, and you don't have to worry about it. And then you can output text and all that. So let's see how we can do this thing. Now we have everything. Why don't we just compile? We can actually come here and compile, and you don't have to do that because it's going to fail. We can build our solution, and then it will fail, and you will be very unhappy because it doesn't know what is this assignment base. So we need to tell what this is. And I just want to make sure that we see that right now we have nothing. So we can actually pretend that we own all the code we write. And that's always a good feeling for me to know that I actually know what I'm doing. And so the first thing we need to do now is we need to find this library. Okay? And then, what do you know? We know that where this library is in the useful files folder. So what we can do here is that, remember the references? This guy is all where the libraries are. So we're going to come to references and right mouse button click and add reference. So this is like I'm going to add the library into my project. So when you click on add reference, you see the same interface. Well, what we are going to do here is we're going to browse. We know where we're going to look for things. And when you browse, you see the same interface. This is a file browser, right? So I'm going to go up one folder. Under useful files, I'm going to see these 2 guys. Okay? And then we need to be very careful in terms of we want the PC version, not the Xbox version. The binaries are different. So I'm going to include the PC version. I'll share a secret with you. I was really nervous last night. I didn't sleep at all. And my brain is not working. Later on, we'll do a little bit math. I don't think I can do it. I'm going to start the code on this side so that I can actually tell you what needs to be done and pretend I'm actually doing stuff. So what I'm doing on this side is to actually start the same thing so that I can cheat.
That's why we have the college students to do the math for you.
Yeah. Anybody can do the math for me now. I just. So look, we have included this mechanic stuff. I can still do. I'm like walking without thinking now. This is a great feeling. It's like I'm flying. I think on drugs feel the same way. don't know. Okay, so anyway, so now I can compile this thing and run, right? So I'm going to compile this. And when I compile, it complains about the constructor. You can't construct. And the reason why I make all this thing fail is I want to point out this. First of all, we need to include the library. Second thing is that in the constructor here, we force the user to tell us what is the coordinate system you want to work in. Remember earlier on we worked with template, we worked with sprite, we worked with images. They're great because they let us verify the conceptual model we have developed. However, we also pointed out that it works in pixel space. Pixel space is evil because your window size change. So we really want to work in a space that we define. And here we are forcing you to do that. Define the space you want to work in. And this is where I was going to cheat because I can't remember what this looks like. Oh, looks here. See, I tell you, if you work with C# for a while, you can't go to C++ anymore. I want to see this in C++. So here it says the constructor expects a world mean and a width of the world. So this is the coordinate system you define for yourself. And it's very convenient because we work in a two-dimensional world. Two-dimensional world is always rectangular. So here is my rectangular world. And define it, how you want to work with this thing. For example, one thing we often do is we decide this point is 0, 0. It doesn't need to be. This can be whatever number you want. And then you will also define the width of your world, not the height, only the width. Why? Because we want to make things simple, that's why. And another reason is that the target hardware for this application is a HDTV. And for HDTV, what you have is you have this 16:9 ratio. We okay with that? It's 16:9 for HDTV, the ratio. So what that means is that if you specify the width, the height is not a variable, it's a constant. So we only let you specify the width. So in this case, what I'm going to do now is I'm going to define my lower left corner to be 0, 0. It doesn't need to be, it's just convenient to do that. And I want to have a width of 15.
I'm sorry.
Please.
When you say world, do you mean you?
I'm going to erase this now.
Well, you did such a good job teaching that I've got it stuck in my brain.
No, thank you very much. You like students like that. It's that people get confused and they all just swallow it and tough it out, and that's not good. So we're going to erase the entire pipeline. We don't want to see the pipeline. We're not graphics people. We're not games people. Those stuff just intimidating. So what I'm going to do now is I'm going to define this, my application window. I'm going to pretend my application window has 0, 0 here and width of 15.
15 what?
Unit.
What?
Unit, 15 unit. Okay. So if your window is 200 pixel wide, then each one of my units, 300, I can't divide very fast. If it's I still can't divide. If it's 300 pixels, then each one of your unit will occupy 20 pixels. Yes? Thank you. So, but then you really don't want to think this because it can be 300 pixels, it can be 600 pixels, it can be 250 pixels. You don't know what it is. And you don't want to be tied down to this thing. So we're not going to see that. We're only going to see this. The first thing I've never developed games in my life, so I shouldn't say the first thing in games development. The first thing in computer graphics, the first thing you want to think about defining something that moves and interacts is to get away from something that's hardware dependent. So pixels are hardware dependent. So we want to work in a coordinate system that suits us. The reason why we define this to be 15 units is because I want to have 15 blocks.
Okay, now I understand.
It's convenient. And each one of my blocks height is 0.5, and then the width is 1.0. Isn't that cool? I don't care how many pixels you have. That's my blocks. Okay, so that's why we're doing this. So I'm going to come out here, and this is constructor, so I'm going to new a vector, and my lower left corner is 0, 0, and then the width of that's it. That's the width of my world, and I think I need one more paren. So syntactically it's correct. It's still not happy. I'm shameless when it comes to cheating on my own stuff. Did you guys see what I did wrong there? Oh, thank you. There we go. Okay, so now if I compile, I'm going to do Control-Shift-B, that will build, and this will build. And this will build. Oh, it builds success. And then when I run, I come to F5, that's debugging run, it crashed. It crashed because it doesn't have the necessary resource. The point I'm trying to make here is that the library is simple, however, it's also very rigid. There are specific things, if you don't have it, it just won't run. And that's why in a professional development environment, you can't do this, okay? Because professionals get very frustrated when it's so rigid. But then we're not professionals. So what we're going to do here is I'm going to do a Shift F5 to come out from debugger. And what's missing here is I need to have font. If you don't have font, it won't run. Okay, now in order to do font, what I need to do now here is that, once again, rigidness. My font comes under content. So what I need to do here is that I need to look at what I will do is under content, I'm going to create a subfolder called resources. I'm going to add new folder. Once again, I'm tightly into the file system. So when I add a new folder, I'm actually adding a new folder into the file system, and this folder's name is resources. R-E-S-O-U-R-C. So it's resources. And then under resources, all my texture, my audio, and my fonts will come under here. So under resources, I'm going to add another new folder. It's called fonts, F-O-N-T-S. Okay? So what I'm doing now is I'm fulfilling the expectation of the library. It's a really stupid library. It's very rigid. And then what I'm going to do now is I'm going to put my font into here. I'm going to do a right mouse button click, add existing item. So we've been going through this thing now. In terms of whenever you want to add a resource into a system, it's exactly the same procedure. I'm going to go find my font. And then my font's under useful files. It's this Arial Sprite font. I'm going to just add that in. Now my font is part of my system. I can compile and I can run, and this will go. So I can compile, I can run. I just compiled, it's successful, and if you type F5, I can run. And we can see that what we're seeing here is a 16:9 ratio of an application window. Okay, now this is our version of the first example we've seen. How exciting. So what we can do now is we can start experimenting a little bit with the library in terms of what I can do is, when all else fail, let's draw a circle. So we will come out here and then let's define a representation for a circle. A circle is just a position. And so I'm speeding up, I'm sorry. So I'm going to have a circle in the instance variable, and then I'm going to allocate memory for my instance variable. And where do you want your circle be? Now we have a good sense of how big our world is. Is 0, 0, 15 units. What's the height? It's 9 point something, right? So if you want to draw a circle somewhere in the middle, you will draw it at x is equal to, say 7.5. So my x, I'm going to put it at 7.5. And I'm going to put y is equal to, let's say 5. So that's where I'm going to put my circle. And did I put it in my constructor? It's okay to put this in the constructor. I'm going to take this out and put in the initialization. Sorry. Okay. If you have it in the constructor, don't worry about it. It's the same. It's okay. It's a rule that if things can be delayed, I don't like to allocate them early. So I want to do them at initialization. In using this library, you never need to allocate memory in the constructor. So the constructor, all you need to do is to specify the bounds of your world, and that's all you need. Okay, so everything will go into initialized world. Initialized world is done, and I come out here in draw world. What I will do is I will draw my circle. So now this is where we really like the IDE. XNA assignment base. I'm going to type tab dot draw circle. The tabbing thing is so cool. You don't need to know the library anymore. And look, it tells you everything it expects. It expects a position of the circle. I'm going to pass my position. And then it expects a radius. What's a good radius? Let's use 0.5 f. It expects a rotation. So here, this library lets you rotate a circle, and we're not going to rotate it. So I'm just going to put in 0.0 here, 0.0 f. And that's the rotation. And then the library lets you specify the boundary color of the circle and the inside color of the circle, and it will do some kind of nice blending for us. So the outside color, I'm going to use color dot, I don't know, blue. And then inside color, center of the, let's use color dot white. Okay? And then lastly, it expects a file name. Right now, I don't have any file name. I'm just going to give it a null string. And then we can see our circle now. Right? So I'm going to compile this thing, F5, compile, run, and ooh, I see my circle. Big deal. But then, now, so we are doing exactly the same thing as we have done in the first hour. So we spent 2 hours doing nothing, except the fact that I hope we have a little bit of appreciation for now we can do geometry now. We can define our coordinate system. And given this framework, I hope we can work in this framework quite comfortably in terms of if I want to move the circle, what would I do? If I want to move the circle around, I'm going to come into here, into update world, and then I'm going to go ask from the gamepad. So here I'm going to define a vector 2, delta, and then I'm going to go ask from the gamepad. I'm cheating on this side. Be very careful now. Our library do not prevent you from working with XNA. You can still see all the XNA functionality. When I type gamepad and start accessing, these are all the XNA functionality. Our library's gamepad is slightly simpler, and I'll show you why. So if you just type gamepad, you're going to get the original XNA version. So what I'm going to do now here is that I'm going to come out here and say XNA assignment base dot gamepad dot. Now we're seeing our library's gamepad. Okay, so we're kind of duplicating things for us, and then we will actually see why. And then I'm going to look for a left thumbstick dot left. The interface is identical. Try to duplicate everything XNA does, and we try to build in some functionality in there. So here is my left thumbstick, and then what I can do is I can do position at equal to delta. This will make it go really fast, because the delta is between 0 to 1, and my world is only 15 units. So if you're not careful, your thing is going to fly away really fast. So well, whatever. So I'm going to compile this and run. And we don't have our gamepad. But what we do right now is that we map to keyboard automatically for you, so your keys will work. Okay? So because it's gone now, because it's so jumpy. And if you type the Q key is mapped to the back key. It's mapped to the back key. So if you type the Q key, it will quit the application. Well, it should. It doesn't. Oh, that's because we're not doing it. How can we make the back key quit the application? So I'm going to come in here and into update world. I'm going to say, how do I quit? I'm going to say if XNA assignment base dot gamepad dot button back click. Oh, this is a function that the XNA don't give us. And we're doing this thing, and this is really dangerous, because in subsequent updates, we try to detect events, and we keep the events. And that's just not right. You cannot keep these things. Okay? So we're keeping events for you, because our users are more naive. So here, you can actually detect the button click. If the button click once, you'll get 1. If you click twice, you get 2. When you're working with XNA, you can detect button down state, you can detect button up state. The transition, you have to do it yourself. Here, we're trying to do that for the user. It's not accurate. So if the button has been clicked, what I'm going to do is I'm going to say this, exit. Yeah. So I'm going to quit. The thing I don't know is, I think this button click is a function. It's not a, yeah. So now if we compile this thing and run, I have a circle, and then if I type Q, it quits. How nice, I know how to quit. So if you want, you have a game that you are spreading seeds, now you can actually detect 1 seed at a time. Each time when the user click, it's only 1 seed. It's not a state anymore. Do we have any question? How hungry are we? Can we give me 10 more? Very hungry? I want to finish to one state. Let's just, I'm going to put in texture and put in sound, and then we'll quit, okay? And then it's all just adding in things. So we're going to put in texture, and then to put in texture in our environment, in this environment, it's very simple. In terms of the process we need to go through here is still the same. So I'm going to come out here under Content, Resources. I'm going to make a new folder. I'm going to make a new directory, and the directory's name is, I think, Textures with an S. I'm a foreigner. I don't know when to use S and when not to use S. It's very, very confusing. So I'm looking, okay, it's textures. So I'm going to add a new folder, and then the folder name is textures, T-E-X-T-U-R-E-S, textures. And then what I will do is I will add the texture file into my folder. And then the library expects any texture file you added in there, you can use it anytime you want. The library will just go look for it. Okay, so what I can do now is I'm going to go add textures into, so it's under resource. At the same level as fonts, there's a texture folder. I'm going to go and add my texture. It's existing item. I'm going to stop now and backtrack and just summarize where we are so that we're not too confused. This is where we are, working with the library. We just went through this B. So we start working with the library. Here we're at C now. We're working with a little bit more media in terms of texture, in terms of sound. So we're at C. If we're at C, then you come look at your structure here. Look at the structure here. We are done with B. We're at C, working with media. If you go under look working with media, you will see that begin template source, there is another useful files folder. And in that folder, what we have is a bunch of textures and some wave files. We're going to look at how we can use all of them. Okay? So I'm going to come out here and I'm going to textures. I'm going to go find my texture. So existing items. And this is in B. So I need to go to C now. I'm going to go up, up, up. I'm going to go to C. Under C, begin template, useful files. I'm going to include my B texture. Some of us just give up. It's like, whatever. Yeah, no, include both of the textures. The audios are different. So thank you very much. Let's include both of them. Let's include both of these guys. So I'm including the background texture also. We have a really beautiful campus, and that texture is our campus. So what I want to show here is that in initialized world, I'm going to use the library one more time here. So besides allocating memory for my position, I'm going to tell the assignment base, I'm going to set my background texture. Okay, so I can have a texture covering my entire background. So background texture, I'm going to use my BG texture. That's my background texture. Just by specifying that, that image would be used to cover your entire background. And I'm going to close that now. That's in my initialized world. And then in my draw, when I'm drawing, we all remember drawing that circle. and we don't have a texture before. So now I can say I will use that texture. I'm just going to use my B texture. Yeah, the B texture. So the texture names are here, and by default, the resource name is just the name itself without the extension. Oh, wow, that helps so much to understand what's going on. So we can run this thing, and then the application becomes a little bit, becomes a little bit more complicated now. Now you can move your B around. And here what we are seeing is the PNG file format. And this is a circle, remember that? So the outside is all transparent, so we don't see it. It looks like it's a nice B. I downloaded all this texture from Microsoft Office Pig. There's a website you can download from Microsoft. This something art, Pig art, clip art. Yes, thank you. That's where I went to, and then you just look for stuff. They have like millions of images there. It's really cool.
What have you told people what this is a picture of? Because people may not know.
That B?
No, behind.
Oh, yes, our campus. Yeah. That's our beautiful campus. It's really new. It's like we are 10 years old. For a university that's 10 years old, it's like, wow, infant. Yeah, we are. We get to do anything we want. Oh my God, this is recorded, isn't it? No, we don't get to do anything we want. We are very good. Well behaved. So anyway, we kind of increase the appearance complexity of the application without doing much, and that's what images do for us. And what we can do now is we can include sound. If you include sound, then suddenly the application becomes kind of interesting. And this is a true story that I did all the work. We did all the work, and all the assignments were done. No audio. It's just not fun. After you put in audio, it's just so much more fun. And I'm not an artist. Okay, let's do this. So let's include audio. And audio is the part where the fact that we understand when you include something, what happened really helps. So I'm going to talk about audio slightly. We are under C useful files. Here we are seeing two things here. There's a file. This is an XACT project file. I don't know the extension. It's probably XACT. And then there is the actual WAV file. So what we're seeing here is that this guy is a description of this guy. And this guy right here, the project file that describes this wave, this is kind of like a proxy. It doesn't actually have anything. We can open this guy and look at it. So I'm going to do my trick on Notepad again. I'm going to start running a Notepad. And here's my Notepad. What I will do is I'm going to drag this file, this ACT file over, and then we can see that this ACT file, this game audio file is actually a text file, and then we can see blah, 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 blah. It's going to describe how audio are worked. And I'll be honest with you, I don't know any of this stuff that I'm seeing, other than the fact that I know this. I know this. This is my bound.wav file. So that file describes the sound, okay? And because sound can be really complicated, what we have in our library is bare minimum. What this means is that as far as we are concerned is that the audio is a unit. It's not one file. It's a unit, and you have to move the entire unit. And this is the point I'm trying to make, is that the unit in this case is these two files. This is a proxy description of what this file is. So what we're going to do now is that we cannot just come in here and include these files anymore. We have to actually copy this file ourselves. Copy this file in the file system. So you need to know where your project is. Do you guys know where's your project? I kind of know where's mine. I think mine is in B, begin template source. So here's my content. Under my content, there's resources. And then these are the folders we've created from within the IDE. Here's my font. Here's my textures. These files are copied over. Now I'm going to come back to my resource now. I'm going to create a new folder here. Typically, you do this from within the IDE. I'm going to come out to the file system and do this because IDE's capability of copying files break down here. If I just include things from the IDE, it's only going to include that proxy file without including the actual WAV file. So I have to copy those things by myself over now. I'm going to be in this folder. I'm going to come here and create a new subfolder. The name must be audio, AUDIO. That's the name of the folder. Okay, so name must be audio. And then in here, I will copy those 2 files I saw earlier over. So I'm going to go over to the other folder there in under useful files. I'm going to select these 2 files. I'm going to copy it, and then I will put it back here. Do you understand what I just did? I copied those 2 audio files over. And then I'm going to go back to the IDE. The audio is the only one that's slightly complicated in that you have to copy each file over. And then I'm going to come into the IDE, and then notice that the audio file is not here. And what I need to do is I need to look at my file system. I see that's here. Remember the center button? It lets you see all the files. And then I'm going to say audio, I'm going to include in project. Now I have everything. Do we all follow that?
Is there a reason why it's different?
Audio, now I'm speaking from general sense. I'm not authority here. My belief is that each WAV file, for example, each sound file can contain many information. And what you want to do is you want to present this information through a proxy. And this is the only file you want to include in your project. So that you don't want to include the actual WAV file, because inside each WAV file you can have many snippets of information, and those snippets will be described by this file. Does that make sense at all? Maybe yes, no? I'm forcing you to nod your head. That's not fair. But that's my understanding.
What I mean is, why, you had fonts and textures, you had to force your own audio folder. Why isn't there an audio folder?
Oh, no, I created the audio. I created an audio folder.
But the fonts and textures were already there.
No.
A standard project.
No. We created it ourselves, one at a time. Like the resources, the fonts and textures, all those things we created. You know, XNA framework do not govern you do things one way or the other. People don't like this when you tell them this is your system structure. They hate it. And there's one more thing we actually need to do. We need to exclude.
I missed a step here, and
Please.
I'm the only one.
Okay.
I thought I got you said go out of the IDE and do it in the file system.
Yes.
I thought I created a subfolder called the audio.
Yes,
But
under
it's not-
resources.
Yeah, but it's not showing up. Yours shows up in your.
Oh, that's because I did this. Center button right here.
Yeah.
If you click that, it will show you all the folders.
Ah.
And then you will go to the audio one, and then you will right click and say include as part of your project.
Thank you. That was the missing step.
Okay, and then I have to come out here, and we don't want the bound file to be the WAV file to be part of the project. So you come and click on the WAV file and exclude that. I'm going to exclude the WAV file. So if I just show the files I have in here, these are all the files I have. You don't need the WAV file, because the WAV file is described by the ACT file.
So I'm confused why you're not just doing the same thing where you make the file here and then add the...
Excellent question, and the answer is this thing. The answer.
Can you repeat the question?
The question is that how come we went through this really long-winded version of including a resource? And the answer is this thing. The IDE is smart enough for the file you say to include, it will include that file. It will copy that file over for you. So if we look at the project, we have resources. And then under resources, I have my audio folder. So here's my audio folder. And my actual audio information is recorded. Say right here, there's my useful files folder. In here, I have my game audio. I have my bound.wav. These two are the resources I need. Now, if I come out here and create the folder and include, I will include my game audio file. This is the only file I want to include. And what will happen is IDE is smart enough to copy this file over. So I will have my game audio here. However, in game audio, I refer to my bound. That's not here. So now if you understand, so that's an excellent question. In terms of now that I understand this is exactly what happened, you can do add audio file, and then you will go out and copy your WAV file over. IDE won't do that for you. So this is the reason why we went through this entire hoo-ha, is to make sure that the WAV file is copied over manually.
It would seem to me that it would have been easier for my brain, tell me if this would have been equivalent, to have done the same thing there, to have created the audio, drop the whatever it was, the exact file, and then gone into Explorer and just...
Absolutely. That's what I should have done.
We've got to the same place.
Absolutely. That's a much better solution. Do you understand? So anyway, now what we have is we have something called bound, and we can actually use it. So I'm going to use the sound cue. And if you excuse me now, I'm going to go back and show you what is in this file. We just did that, but I'm going to show you what's really in there. So we'll come out to Explorer again, and you can actually double-click on this file. XNA 2 gives you a utility function that lets you... Oh, good, I'm so glad it worked. They actually let you work with this. I have no idea what most of these things are. I'm not a sound artist, and this stuff scares me. But then I do know this thing. This guy right here, I'm going to double-click it. It's going to give me my wave. This is the wave file I have. Okay? And then from each wave file you have, you can create a cue. You can create a sound cue. You can create at least one sound cue. You can create probably more. I don't know how to. But then as far as you know, being a beginner on this thing, what we can do is I'm going to double click the game sound here. These are the only two things I know how to work with. So wave bank is the actual wave file. If you plug in the microphone here and start the recording and go hello, you can do that. You will record a wave file. And that wave file you can use here. And in fact, all the sound effects you hear, I generated them. 2 o'clock in the morning, I can't find good enough sound. I go boop. That's it. And you'll be surprised how kaboom works when something explodes. Much better than not having anything. So this is the wave file. And then here is my sound and cue. This guy right here is what we will play, the cue. We will play this cue. Okay? Now you're thinking like, oh my God, what's going on here? I'm going to delete everything. I'm going to delete everything. You don't have to, but I will. Okay, I'm going to delete this. I'm going to delete this. And I will delete that. And pretend I don't have anything. And then what you will do is you will come out here, record your WAV file, and then you just drop it in here. I just drag and drop the WAV file. This is a poor man's trying to work with sound. I drag the WAV file and put it in here. And then what you can do from the wave, you can think of the wave being collection of all the information you want, sound being the snippets you want. So I'm going to drag my wave into my cue. That will create a cue for me, and I can play this. And use cue, because our library is so primitive, we do not have more than one track. There's only one channel. So at any point, you can only play one thing. And once you start playing a sound, you will continue to play until it's done. So what all this says is that you cannot have background music going. And you want to use cue as a way to tell the user something has happened. Okay? And then you want this thing to be as short as possible so it doesn't occupy too much time. So now you can do that. And then now we have a cue called bound. And because we have a cue called bound because I put it into my game audio and this file is saved. So I'm going to save this file And what I have now is in my code, I can actually have game audio now. And what I want to do now is that when my ball, when my circle comes to the when my circle approaches the boundary of my window, I want to play a cue and let the user know. Okay? And so here's in my update world. That's all I need to change now. In my update world, I'm going to check XNA assignment base.world max.x. So we see now that XNA assignment base tells you the max of the world, the max and min of the world. Here is the world max, here's the world mean. These two data structure tells you the corner of your world. So what I can do now is if I want to move outside on the right side, I will tell myself. So here I can say max, not dot max, world max. Thank you. You are so kind. So my position, if my position dot x is greater than world max, what I would do is I don't know. Let's make sure that it doesn't go out. So I'm going to bound it to just clip it to there, and then I will play a cue. I will play a cue for 0.5 second, and then the cue's name is called bound. So when you want to go outside of the world, I force you back and clip you to there, and I play a sound for you saying that, hey, something bad is happening. And we can do this for all the bounds, right? So after that, we can compile and run this thing, and when I come to the I think that one I stole from the game from the default game from XNA. I shouldn't say steal. I borrowed from XNA, the soundtrack. I borrowed from the XNA default game. There's some pretty high-tech soundtrack in there that you can use. Some of my game actually has turn left, turn right, turn right, and it's kind of nice. How's that? Sorry. I was admiring my own code. I mean my program. So yeah, if your position is greater than world max, then you want to just clamp it, and then you can play a cue. Yes?
So if your cue is longer than half a second, will it only play the first half second?
Exactly right, yeah. It doesn't scale it. So we can try that. You know, if we play this for 0.1 second, and then my sense is I'm not a gamer. My sense is that any kind of feedback is fine. You know that something is happening. Now it gives you a sense of stuck. I guess it conveys different sense of things. One thing is like bouncing. This one is like less bouncy. And there, you know, so what we have seen is that if you want to work in, after understanding the framework of what XNA provides us, we simplified it, and then after jumping through these few hoops, then we can now work with this library and build something fun. Then we can, the hope is that with a library like this thing, after you jump through the hoops of the resources, you can concentrate on the logic. You know, like building a game, graphics should be secondary. The logic is the important part. And when we think about the block breaker game, then it's the logic, what's the logic that's required? And, you know, we'll start from here. We'll build 3 classes in the afternoon, three classes, and then we'll be done. I think we will be done in like an hour in the afternoon. Well, see how fast I can talk. Are there any questions?
One clarification.
Please.
Did you say with your library that I cannot also run background music at the same time?
You cannot. You can, but then you have to do it yourself. In terms,
XNA assignment base won't do that.
No. It's too intimidating for me. You know, I got this in working. It's important to have sound effect. Okay. No, I mean, I do admit, I wish I can spend more time on it. It would be more fun. Are there any other questions? We're all hungry, right? Let's go for food. Let's take let's come back at 1. Is that enough time? Okay. And then let's finish in 1 hour. Thank you. So I'll see you guys in the afternoon.